Hello dear students, welcome back to the session. So previous class, that is in the previous session we discussed about meaning of what? Capacitor and the capacitance of a capacitor, and also discussed about what capacitance of parallel plate capacitor. But in this class I am going to discuss about combination of capacitors. So, in order to get a required capacitance, sometimes we are in a need of maximum capacitance. Sometimes we may be in the need of what? Minimum capacitance, based on a requirement, whether you are in a need of maximum capacitance or you are in a need of minimum capacitance. Based on the requirement number of capacitors, either they are connected in series or else they are connected in parallel. Concentrate here, there are two types of combination of capacitors. Number of capacitors may be connected in series or number of capacitors may be connected in parallel. It's all depends on whether you are in a need of maximum capacitance or else you are in a need of what? The minimum capacitance. Suppose if you are expecting minimum capacitance from number of capacitors, you have number of capacitors but your expectation is you have to get minimum capacitance out of what? Number of capacitors. Then you are going for series combination of capacitors. Concentrate here. When you are going to prefer series combination of capacitors, series combination of capacitors is used to get the minimum capacitance. ನಿಮಗೆ ಯಾವಾಗ ಮಿನಿಮಮ್ ಕೆಪಾಸಿಟನ್ಸ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇದೆ ಅಂತ ಸಿಚುವೇಶನ್ ನಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ನ ಸಿರೀಸ್ ನಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಸಪೋಸ್ ಇಫ್ ಯು ಆರ್ ಇನ್ ನೀಡ್ ಆಫ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೆಪಾಸಿಟನ್ಸ್ ಔಟ್ ಆಫ್ ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್, ನಿಮ್ಮ ಹತ್ರ ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇದ್ದಾವೆ but you are in need of what? Maximum capacitance. Then capacitors are connected in parallel. Concentrate here. Series combination of capacitors is used to get minimum capacitance, whereas parallel combination of capacitors is used to get the maximum capacitance. So first I will consider series combination of capacitors. Series combination of capacitors. Combination of capacitors. Under this heading, we are going to derive an expression for total capacitance when the number of capacitors are connected in series. Number of capacitors na series nalli connect ಮಾಡ್ಕೊಂಡು ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, we are going to calculate the total capacitance of the combination. So then when does number of capacitors are said to be connected in series? Which type of arrangement of the capacitors is said to be series combination? We have some conditions here. Number of capacitors are said to be connected in series provided they should be connected end to end. ನಿಮ್ಮ ಹತ್ರ ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇದ್ದಾವೆ, ಸಪೋಸ್ ಆ ಎಲ್ಲ ಕೆಪಾಸಿಟರ್ಸ್ನ ಎಂಡ್ ಟು ಎಂಡ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಅಂತ ಕಾಂಬಿನೇಷನ್ಗೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ಸಿರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್. ಸೊ ವಾಟ್ ಈಸ್ ಸಿರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಕೆಪಾಸಿಟರ್? ಇನ್ ವಿಚ್ ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್, ದಿಸ್ ಈಸ್ ದ ಫಸ್ಟ್ ಕೆಪಾಸಿಟರ್ connected to what? Second capacitor connected to what? Third capacitor, so on. First capacitor, second capacitor, third capacitor, the number of capacitors are connected in such a way that they are connected end to end. When the number of capacitors are connected end to end, then such a type of combination will call it as a series combination. This is first capacitor. It is connected to C1 is a capacitance of first capacitor. C2 is a capacitance of second capacitor. C3 is a capacitance of what? Third capacitor. First capacitor of capacitance C1. Second capacitor of capacitance C2. Third capacitor of capacitance C3 are connected end to end. Then such a type of combination, we'll call it as a what? Series combination. In the first case, I will consider C1, C2 and C3 are the three capacitors which are connected in series. So our aim is to determine total capacitance, that is CS. Total capacitance CS of three capacitors which are connected in series. Three capacitors series nalli connect madidre what will be the total capacitance of what? Entire combination. That we have to determine. In the first step, what is series combination of capacitors? Number of capacitors are said to be connected in series. Number of capacitors are said to be connected in series provided they should be connected end to end here. Okay. So across this series combination, I am going to what? Apply potential difference with the help of the battery. What is V? V is a potential difference which is applied across which combination? Series combination. What happens when the potential difference is applied across a series combination of capacitors? What happens when the potential difference or battery is connected across the series combination? All the capacitors will start storing the charges. ಯಾವಾಗ ನೀವು ಕಾಂಬಿನೇಷನ್ಗೆ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀರಿ ಅಥವಾ ವೋಲ್ಟೇಜ್ ನ ಕೊಡ್ತೀರಿ or else you are applying the potential difference, the capacitors will start storing the charges. Very interesting. When the number of capacitors are connected in series, concentrate on the sentence. When the number of capacitors are connected in series, all the capacitors are going to store same charge. ಅರ್ಥ ಆಗ್ತಾ ಇದೆನಾ? Series combination property. What is the property of series combination? When number of capacitors are connected in series, charge stored by each capacitors will be same. How much charge the C1 is storing, same charge is stored by what? C2, and the same charge is stored by what? C3. In general, charge on each capacitors will be same here. Then what is the charge? First capacitor is going to store a charge of Q. Other plate is what? Minus Q. Second capacitor is also going to store a charge plus Q. Other plate is minus Q. Third capacitor is also same, plus Q, minus Q. But the magnitude of the charge stored by each capacitor will be same when the number of capacitors are connected in series. Then, second important property, you are applying some voltage or potential difference. Say for example, if you applied 10 volt of potential difference here. When you are applying the potential difference with the help of what? Battery, that potential difference will be divided among the capacitors. Charge same irutte, ella capacitor mele charge same irutte. But what happens? Potential will be dividing. Andre potential difference across first capacitor will not be equals to potential difference across second capacitor and will not be equals to potential difference across third capacitor. Potential difference across each capacitors will be different. But charge stored by what? All the capacitors will be same. That is the property of what? Series combination. Ee sentence na repeatedly rewind ಮಾಡಿ ಕೇಳ್ಕೊಳ್ರಿ. What is the property of series combination? When the number of capacitors are connected in series, charge stored by each capacitors will be same, that is Q. But potential difference across the capacitors will not be same. and whatever the total potential difference you are applying here, that potential difference is dividing among the capacitors. ಇಲ್ಲಿ ಕೊಟ್ಟಂತ ವೋಲ್ಟೇಜ್ ಏನಿರುತ್ತೆ ಅಥವಾ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಏನಿರುತ್ತೆ, based on what? Capacitor capacity, it is going to dividing. Therefore, it is divided into how many parts here? 3 parts. What is V1? V1 is a potential difference across first capacitor. V2 is a potential difference across second capacitor. V3 is a potential difference across third capacitor. Potential is dividing. Potential is dividing, but charge remains the same. That is the property of which combination here? Series combination of what? Capacitor. Now, ಇನ್ನೊಂದು ಸರ್ತಿ sentence na repeat ಮಾಡ್ತೀನಿ. Concentrate on the points here. Number of capacitors are said to be connected in series, provided they should be connected end to end. First point. Second point. When the number of capacitors are connected in series, charge stored by each capacitors will be same. Ella capacitor same amount of charge na store ಮಾಡ್ಕೋತವೆ. Second point. Third point, potential difference across the capacitors will be different. Charge same ಇರಬಹುದು, but potential difference across the capacitor will be different. That is, V1 is potential difference across first capacitor, V2 is potential difference across second capacitor, V3 is potential difference across third capacitor. Potential difference will not be same here. That is, potential difference, I mean whatever the potential you are applying, it is dividing among the capacitors in such a way that V should be equals to, V should be equals to what? V1 plus V2 plus V3. I will call this as equation number 1. Andre total potential difference across the combination is equals to sum of the potential difference across each capacitors. ಒಂದು ವೇಳೆ ಎರಡೇ capacitors ಇದ್ವು ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Suppose we have only 2 capacitors which are connected in series. That is C1 and C2 are connected in series. Then V should be equals to what? V1 plus V2. V equals to V1 plus V2. Suppose 4 capacitors are connected in series. Then V is equals to V1 plus V2 plus V3 plus V4. If n number of capacitors are connected in series, all n number of capacitors will be having same charge. But V should be equals to V1 plus V2 plus V3 plus V4 plus up to Vn. Potential is dividing, charge remains same. That is the property of what? Series combination. Therefore, V is equals to V1 plus V2 plus V3. This is the condition for series combination of what? Capacitor. As I said you, under this heading, I am going to derive the expression for total capacitance when number of capacitors are connected in series. Let me derive the total capacitance here. V is equals to V1 plus V2 plus V3. Okay. Next step, we will substitute V value, V1 value, V2 value and V3 value by using this formula. We know that what is C? C is equals to Q by V. This implies V is equals to what? Q by C. We have the general formula. C is equals to Q by V, then V is equals to Q by C. If V is equals to Q by C, this implies what should be V1? V1 should be Q by C1. V2 should be Q by C2. V3 should be what? Q by C3. You should not write Q1 by C1, Q2 by C2, Q3 by C3 because charge on each capacitor will be same here. Therefore, V1 is a potential difference across first capacitor, Q by C1. V2 is a potential difference across second capacitor, Q by C2. V3 equals to Q by C3 and V, that is total potential difference, V is equals to Q by C. What is C here? C is a total capacitance of the combination. C is a total capacitance of the combination. C1 is a capacitance of first capacitor. C2 is a capacitance of second capacitor. C3 is a capacitance of third capacitor, whereas C is a capacitance of what? Total circuit or total combination. Now I am going to substitute V value, V1 value, V2 value, V3 value in equation number 1. Substitute these values. Substitute in equation number 1. Substitute here. What is V? V is equals to what? Q by C, which is equals to V1 Q by C1 plus V2 Q by C2 plus V3 Q by C3. Okay. Next, Q by C as it is. Take Q common here, RHS. If you take Q common, I am left with 1 by C1 plus 1 by C2 plus 1 by C3. Okay. Q and Q gets cancelled. I am left with 1 by C is equals to 1 by C1 plus 1 by C2 plus 1 by C3. So what is C? C is a total capacitance, or else I can write this as 1 by Cs is equals to 1 by C1 plus 1 by C2 plus 1 by C3, which is an expression for total capacitance of how many capacitors? 3 capacitors which are connected in series. ಒಂದು ವೇಳೆ 2 capacitors ಕೊಟ್ಟಿದ್ರೆ, suppose if they have given only 2 capacitors, then 1 by Cs should be equals to 1 by C1 plus 1 by C2, which is an expression for capacitance of what? How many capacitors? 3 capacitors which are connected in series. So in the examination generally they might be asking you to derive an expression for capacitance of 3 capacitors connected in series, or capacitance of what? 2 capacitors which are connected in series. So this is most expected 3-mark question for examination. Already I have shared the notes in the previous video. You can what? Write the notes based on the explanation what I have given, but this is how you are going to calculate the capacitance of what? Series combination of capacitor. So I will make one special video on, separate video on information, more information about what a series combination of capacitors. Those points may be useful for you to what? Attempt some competitive examination. In the first step, we will derive the expression for capacitance of series combination. Then we will derive the expression for capacitance of parallel combination. Third video session will be based on some of the worth noticeable points on series combination as well as parallel combination. As of now, we'll stop here only and practice how to calculate the total capacitance of what? 3 capacitors which are connected in series. Okay, thank you.